Alright, hello, welcome to another Emacs tutorial. My name is Daniel.
And my name is Duran. We are both coaches at Udacity.
And we're going to talk about this Emacs mode called Skewer mode. So Skewer mode is made by this guy named Skewer, and it's a way you can do live web development within Emacs. So essentially, when you're doing web development, you can make some changes to your HTML, CSS, and JavaScript and refresh the page, right? Refresh the page, and every time you make a new change, you can refresh the page. But what Skewer mode allows you to do is actually not having to do that refresh step and actually just update your code straight from Emacs, right? So it sends code from Emacs all the way to your browser automatically. So let's go over the sort of steps to install and use Skewer mode. You're going to install it via Melpa, and the dependencies for this are the simple HTTPD package as well as the JS2 package. So we're going to interact with these two packages directly to set up Skewer mode. There's some usage steps here where essentially to automate the whole process of having Skewer mode set up, we're going to actually add hooks. So every time you load a new buffer with an HTML mode, CSS mode, or JS2 mode, you'll just load the appropriate Skewer modes for those particular modes to actually send HTML, CSS, or JavaScript to the browser.
Yeah, and so the modern way to do it is just call this one command, right? Skewer-setup, and it calls those three hooks. Is that right? So
this one function already essentially does this for you. So in your config file, your init file, just say Skewer setup, and it'll automatically run these hooks for you.
And as a reminder, what the first line says is basically every time you run JS2 mode, you also want to load Skewer mode.
Mm-hmm. All right, so the commands for Skewer mode to say send code from Emacs to your browser are very much similar to the way you actually run Lisp code in your Emacs. So you can do Control-X, Control-E, which sends, or it says right here, it evaluates the form before the point. So it actually sends, so say if I'm in this line here, and I want to run the script tag, it's going to actually send that to the browser, right? Same thing with Control-M, Control-Meta-X to evaluate the whole top level form around the point. You can load the current buffer with this command, as well as make a whole REPL buffer with this command.
Yeah, so we'll talk about a form, for example, in HTML means in the script tag, as Daniel was saying, or in CSS it means everything between the curly braces and in a CSS declaration. So.
Mm-hmm. All right, so here are individual commands for this is for JavaScript and Skewer mode, this is for CSS, and also this is for HTML. So here's some more instructions on how to get set up with Skewer mode, and here's the manual version as well. So let's go over the manual version just so we can see how this works under the hood. So what happens here is that you're going to start an HTTP server using the package HTTP start, and this is the command to run it. So what this is going to do is actually host the Skewer file here. So once I run HTTPD start, which I've already done, I'm going to actually go to this URL here, and you'll see that the Skewer sort of program is running for us. And that's why we need to load this URL in our HTML file, because we're going to use this to interact with Skewer.
Wait, so explain, what did we just see when we went to that URL? What did that tell us?
So when we go to the URL, this is just the script. You don't need to know anything about this. This is how Skewer functions.
But it tells us this is running, so basically means that on listening to port 8080 and you do /Skewer, something is there.
Right.
We actually see something.
So let me go to actually my processes here for Emacs, and we see that we have all these HTTP connections happening. So if I actually refresh this page, a new one gets happening, right? So here's a new request that just got fetched. So this is actually running a server from Emacs.
Okay, because you already ran HTTPD start. So you started the HTTP daemon.
Mm-hmm.
Cool.
Exactly. So let's move on with with the demo actually. So here's the program we're going to be demoing with.
Yeah, so this is, if you're familiar with the front-end nanodegree, this is Project 3. It's the object-oriented JavaScript project. You have to write a game where you move this character across the screen and you try not to get hit by these enemies, these bugs.
Mm-hmm. So, when we're doing normal web development, let me go to the CSS file here. If we make a change, say like we add a new header, here's a new header. We save the file, we refresh, and it shows up, right? We like, oh, I want to change the background color, background to red. We save it, refresh, and then here's a new background color, right? But with Skewer mode, we can essentially just update these things on the fly. So say let me refresh because this red background is pretty jarring. I have this header, I want to like update it, like here's a new header with some more text. And I can say Skewer mode. I have Skewer mode running here in my HTML mode, so I can run the command Control Meta X, and it actually runs this form and it updates this header into the browser, right? Same thing with same thing with CSS. So I can say change that background color to some audacious orange. Send this to the browser and it updates it, and you notice how like even the game is running still. The bugs here and the character here are in the same position. Every time I refresh, if I refresh the page, these bugs are going to be starting again from the left side.
Yeah.
And since I didn't save these files, the whole background and all the HTML did not get updated.
So no refresh actually happened, right?
Right.
You must have been modifying the DOM and the CSS live. Yeah.
Exactly. And remember, it's important to have the script tag loaded into your HTML file because that's how your page here is going to listen to Skewer.
Okay, right. Oh, so that was one of the setup requirements. So we need that tag.
Yeah. So if I didn't have this tag and I save this and I refresh, and I want to like remove this text, all right, and I want to actually send this with Control Meta X, nothing's going to be updated because that tag's not actually being listened to on this page.
Oh, yeah.
So I'm going to undo that work and have that tag loaded. Refresh the page just so that script is loaded. And now let's do a demo with the JavaScript way to like just insert JavaScript into the browser. So this game here is running with all these script tags. We have the resources, JavaScript file, app file, and engine file. We're not going to actually show these files in this demo, but we actually are going to manipulate the game because it's loaded with JavaScript. So here we're going to have the demo file. And because we're running JavaScript here, setting it from Emacs to the browser can do a lot of interesting interactive work. So say you want to know so we have a variable here called all enemies, and this just represents the number of bugs we have on the screen. So if I want to know how many enemies there are being displayed, we just store this all enemies thing. It's just a simple array.
Yeah, normally we'd have to look at it in the console, right? So what if we open the console and check?
So we open the console with DevTools. Open the console. You can do all enemies, .length. And we see there are 3 enemies. I can do the same thing in Emacs, right? So I have this all enemies .length line here, and I can evaluate it with Control X, Control E, and I see right here in the mini buffer, it shows 3, right? It shows 3 as the length. So I don't actually have to touch the browser and go to the console. I can just do it all from Emacs. So we can not just show property values from Emacs, we can also like manipulate the game. So here we're going to take the first enemy in the list, change its velocity to be 5 times more than it is right now, right? So all the bugs are going at a pretty kind of slow pace right now, but if we run this code, we see that one of them is just zooming past by the screen, right? And in this particular game, the enemies are getting recreated every time they go from right to left. So that's why we don't see that same bug flying over. It just leaves the screen and a new one comes in. But we can do more things than that, right? We can actually add new enemies. Like we said, this is a simple array, so we're going to push. We're going to do a push here and just add a new enemy. So I'm going to do this a lot of times. See, oh, the whole army of bugs, they're just coming into the screen now. So we can actually ask Emacs how many enemies are on the screen. So we can say, oh, there's 22.
22.
Right, so we just keep adding them. Here's 1, 2, 3, 25. So we just like do an interactive development here. See, like, okay, if we're building a game, like what are the amount of enemies we want on the screen, just so it's like fun, playable, and like the player can still win. Like in this case, the objective of the game is for this guy to reach the end on the top and like go past all the bugs and reach the water, right? This is quite a lot of bugs to like reach that objective, so we can like just clear it out with this line here to just empty out and make all enemies to be a new array, and then we can like push more enemies on.
And we can pop them.
We can pop them, right? So they can now disappear right before our very eyes. We also push them. So here is, remember the line here that we made one bug go 5 times faster, and then we can this is with Control X, Control E. So here's a for loop that we have in this demo. All it's saying is we're going to take all the bugs here and make them go faster, at most 4 times faster, but we don't know. It's a math.random, right? So if I do Control X, Control E here, we get an error saying cannot read property velocity x of undefined, and then we get Skewer just giving us an error here, and it even tells us what expression it's trying to evaluate. It's trying to evaluate just these curly braces in between the for loop body, but we actually want to evaluate the whole for loop, right? Not just the body, so it binds all these variables. So we're not going to use Control X, Control E. We're going to use Control Meta X to actually evaluate the whole form at the point. As you remember from the README, there's multiple commands. Control X, Control E just evaluates the current line, but if you want to evaluate the whole form, you use the other command. So I'm going to go back to this buffer. Instead of pressing, I'm going to now press Control Meta X. Now we see all these bugs going a little bit faster, right? So we can do a lot of interactive development again with Skewer mode. Just one note, if you're having trouble running Skewer mode, maybe you're getting like some AST error, remember that one of the dependencies for Skewer mode is to have JS2 mode, right? So here I'm running JS2 mode in this current buffer, and if I had JavaScript mode, which is the built-in JavaScript mode for Emacs, we have different syntax highlighting, but also if I run Skewer mode, and I try to run one of these things, it says no JavaScript AST available. So JS2 mode provides this JavaScript AST right for Skewer mode, so that's how Skewer mode knows what forms to send to the browser. So it's really important to have JS2 mode running. Remember with that hook that we set up from the README, every time you load JS2 mode, it's going to load Skewer mode.
Awesome. Okay, cool. And we can now push new enemies if we wanted, because we're back in.
Push new enemies.
All right, that's pretty cool. So so this was a demo of Skewer mode, which allowed us to edit HTML, to edit CSS, and to edit JavaScript live in the browser.
Yeah,
pretty cool stuff.
All right, that's all we have for you today. So have fun with this.
All right, thanks for tuning in.